Hi, mathematicians. We're going to talk about the big ideas around horizontal and vertical lines. At the end of this video, you will be able to write horizontal lines and graph horizontal lines. Before we summarize our big ideas, let's look back over the opener, which you should have already completed using Desmos on your own as an exploration. So for question 1 and 2, I hope you noticed that the y values were the same within each of those problems, and then the equation was y equals 5 for number 1 and y equals -4 for number 2. Everywhere along each of these lines, the y value was the same, which is why it makes sense that the equation is just y equals 5. The x doesn't matter because the y is always -5 for any given x value. The same was true for number 2, except for instead of looking at 5, our y values are -4 anywhere along here. If I pick a random point on that line, this point right here would be 8, -4. Doesn't matter where you pick a point. This point right here is -10, -4. Everywhere along here, the y value is -4. So that would make sense that the equation is y equals -4. Let's talk about slope. So slope is the change in y and change over change in x, or rise over run. And you can think about it either way. I put a table here to look at if you go from -3, and I'm going to use my x-axis as my number line just to view that. If you go from -3 to +2, how many spaces is that? You've just increased by 5. So this is +5 here. If I am going between 5 and 5, there's no difference. If I subtract those, I'm going to get 0. You could think of that as +0, -0. It doesn't matter. It is just a difference of 0. And so change in y over the change in x is going to be 0 over 5. 0 divided by anything is going to be 0. It doesn't matter what you're dividing by. Any number divided into 0, 0 divided by any number is always going to be 0. Similarly, if you think about this as rise over run, there is no rise for a horizontal line. It does not, the x changes, but the y does not. So there's no change in y. The run can be anything. I often just put a little hashtag there, which represents number. 0 divided by any number is going to be 0. So you can think about that in a couple of ways. But our slope is going to be 0 for any horizontal line. This isn't really something you need to memorize because you can kind of think through that using the logic and the slope formula or rate of change. Look back at your opener for question 3 and 4. Again, you should have already done this using Desmo. Pause and go back to the opener video if you haven't done that. So looking here, hopefully you saw that the x values were the same. And that meant the equation was x equals -7 and y equals 3, respectively. And you can see those plotted here. Those should be plotted on your paper. And then for slope for these, it's still rise over run. Here we have a rise. I just counted the boxes between there for my rise of 7, and then there's no run. It's not changing in y at all. It's just staying at -7, so that's 0. And 7 divided by 0, you can't divide by 0. It comes out to an undefined value in math. So we just say that that's undefined. And that's the same as if you look at number 4. Again, I just counted my boxes for my rise as one way to explore this. I got 8 for my rise, which I wrote here. The run, it's not going right or left at all. There's no change. And you can see if I subtracted 3 minus 3, I would get 0. 8 divided by 0, again, not allowed to divide by 0. And so it is undefined. And if all lines in the form of y equals any number, we're going to use b to represent that any number, will be horizontal. And you can sketch what that looks like. And these lines, these horizontal lines, will have a slope of 0. All lines in the form of x equals any number, which we'll represent with a, will be vertical. And vertical lines go up and down. So those are straight up and down, and they always have a slope of undefined. Like I said before, you do not need to memorize this. You know how to find slope, and you can pick any 2 points on a vertical or a horizontal line and calculate the slope either with rise over run or the change in y over the change in x to confirm that. Horizontal and vertical lines represent special cases. So notice that these special cases only have one variable in the equation, just something to make a note of. You will graph these lines for number 7 on your given paper graph and label each line. So you're going to label them either with the A or with y equals 4, the equation. They're pretty short. And then you're going to write in this box describing how you can tell if it's horizontal and vertical from its given equation, and describe the way you can remember it for your future self. How are you going to remember this to look back over your notes? 8 we'll do together. Graph the lines below, label each line. For A, y equals 5. So you want to think about where is y equals 5, and the first thing I like to do is label my x and y axes. So I'm going to label my horizontal axis x and my vertical axis y. And I'm looking along my y-axis then. This is my y-axis. Where is y5? Y is 5 right here. Y is 5 also here as well. This point is 2, 5, just like this point right here is 0, 5. This point over here is negative 7, 5. I'm doing this just to show you that everywhere the y value is 5 is going to fall along this line, which is why this is the line that represents the equation y equals 5. Keep in mind that the equation y equals 5 means that y is 5 for any x value. To graph B, y equals negative 3. Again, I'm going to look along my y-axis for where y is negative 3. That gives me a point to go through. I need to go through all the points in which y is negative 3, which would be any point along this horizontal line. You don't have to actually plot points, but I think at the beginning it can help us visualize and see that the y value is negative 3 for everything along this red line, which we need to label. You can label it with the B or with y equals negative 3 or both. For question C, I'm looking at where x is negative 4. And again, my x-axis is right here. So now I'm looking along the x-axis to find where x is negative 4. And that's going to be right here. And again, you can put points like up here. This point right here is negative 4, 2. Way down here, this point is negative 4, negative 7. Anywhere along this vertical line is where x is equal to negative 4. To graph D, I'm going to look along the x-axis again and find where is x1. That's right here. You can pick any point where x is 1. So this point right here would be 1, 3. This point up here would be 1, 8. Anywhere along this line, this vertical line, is where x is equal to 1. So notice I've labeled A, B, C, and D with the equation or the letter. You will want to do the same for number 7. For questions 9 and 10, you are going to graph them on their corresponding coordinate planes. In summary, you're going to look at which coordinate is the same along the line. If all the x's are the same, then you know the equation is going to be x is whatever that value is. If all of the y's are the same value, then the equation is going to be y equals whatever that value is. There's only one variable used in the equation of a horizontal or vertical line.